Welcome to Module 11. In this module, we'll focus on the PHP injection vulnerability. This vulnerability occurs where a user has the opportunity to execute a malicious PHP code by modifying the parameters passed to a web application. This situation could take place if input parameters are passed into the PHP functions that allow the direct or indirect PHP code execution. The first function group are the include family functions, include, require, and require once, which serve to include and parse files containing PHP code. The second function of this type is eval, which parses and executes provided strings. The third function is preg_replace, used to verify regular expressions. The parameter e could be passed to this function, allowing for the execution of PHP code passed in a part of a regular expression. As the two latter functions are rarely utilized in standard web applications, we'll focus on the first function. This sample source code will help you understand the concept. You can see here a simple PHP script which utilizes the user-provided variable site for specifying which page should be added to the include function. The content of the website is provided depending on a specified file. As we can see, user-provided parameters are not filtered in any manner. A user has virtually full control over the file name. Let's see how this works in practice. We can browse the website, and as we're doing so, the file names in the address bar are changing. Assume that a hacker has successfully uploaded a file which contains a PHP code to the server. Perhaps you're a bit skeptical. After all, uploading PHP files is certainly disallowed by the site, or the service doesn't accept any files from users. It's common, though, that websites allow users to upload avatars, pictures, and other image files. Let's see if an attacker can still smuggle in a malicious PHP code if files are checked for correct format. You can see here a specially crafted image that looks like a normal JPEG file. Its content is displayed. All image functions will interpret it as a correct image file. But let's take a look at what's hidden inside. As we can see, PHP code has been embedded in the image. Let's try to pass it in the address bar. As you can see, the script injected into the image has been executed. But even if an application has disabled uploading images, a hacker could still use other vulnerabilities to launch a PHP injection attack. File operations in PHP, like including, allow not only direct file references but also enable protocols such as FTP, HTTP, and special data protocol. In the case of data protocol, it is possible to pass file content in protocol reference parameters since the file is generated on the spot. The data is encoded in base 64. Let's use an online encoder to generate an encoded string. Try to encode the following string, converting it into a base 64 string. Use special data stream syntax and paste the encoded PHP code. As we can see, the code has been executed. Let's try to think of how we can protect ourselves against this attack. The first solution is to modify the configuration of PHP ini. The allow URL include option might be used to enable or disable the inclusion of special files which are accessed through the protocols we've mentioned. After disabling the function, you need to restart the server for changes to take effect. As you can see, this time the attack has failed because the options were disabled. Attacks which utilize images are, however, still feasible. As you can see, the underlying cause of the problem is the fact that users practically have full control over the string passed to the include function. You can deal with this by adding static extensions to included files. By doing this, we can prevent an attacker from manipulating the extension. The image has not been included this time. Controlling extensions in this way is enough for PHP 5.3 and newer editions, but older PHP versions allowed the usage of special character %00. The null byte, or end of string marker, was placed in the target string passed to system functions, causing the extension included by a web developer to be dropped. Since this vulnerability was often exploited for attacks, while the need to include the %00 marker in user-provided parameters was rare, the character has been disabled. You can also specify a folder in which the function include will operate to prevent users from tampering with the beginnings of file names and disable special protocols. The next step is to use the preg replace function to remove the dot and slash characters, which makes it impossible for a potential attacker to control the inclusion path. Creating a list of files which can be included and blocking all other references seems like the best solution. If you can't implement this method, try to deter a potential attacker by filtering input. That's all in Module 11. Thank you for your attention and see you in the next module, which will cover the direct static code injection attack. See you there.